Imagine a clock that doesn't tick at a steady rhythm. Instead, its hands slow, halting ever so gradually, as if time itself hesitates. Now, place this clock not in a quiet room, but somewhere beyond Earth, somewhere in the cold, silent depths of space. Here, time doesn't just bend, it dilates, stretches, and sometimes even warps in ways that defy our everyday experience. This is not the realm of science fiction or abstract theory. It is an extraordinary truth etched into the fabric of the universe, a cosmic puzzle that challenges our most fundamental understanding of reality. What if I told you that astronauts orbiting Earth live slightly longer lives compared to those standing firmly on the surface? Or that a signal sent from a satellite doesn't just traverse distance, but travels through a time altered by invisible cosmic forces? In this strange theater, where gravity and velocity dance, time slows down, not because clocks break or gears jam, but because the very essence of time shifts its flow. And yet, this slowing down isn't tranquil or predictable. It ripples through moments, unfolding paradoxes that tug at the mind's limits. The story begins not with planets or rockets, but with light massless, constant, yet strangely intertwined with time's ebb and flow. Light's steady speed is the cosmic speed limit, and it holds the secret to why time clocks slow in gravity's grip or when moving at blistering speeds. But beyond the math and equations, pause to consider the emotional weight of this phenomenon. Time, our most cherished companion, the slow accompaniment to every heartbeat, every memory, is not as stable or reliable as it seems. Throughout history, human beings have sought to measure and master time through calendars, clocks, and watches. Yet, in the grand cosmic stage, time remains elusive. The ticking seconds you count on Earth can outpace those measured just a few hundred kilometers away, and even more so far beyond. This subtle difference grows monumental with distance and speed, revealing that time is not a universal constant but a deeply local experience, a personal rhythm shaped by location and motion. One of the strangest implications emerges when we think beyond humans and machines. Imagine if time dilation could affect the fundamental processes of life itself. Cells aging differently, memories stretching across broader spans, and perception itself bending. What does this mean for future space travelers? How will these shifts challenge our conceptions of existence, identity, and the very continuity of self? What emotional toll would it take to live where tomorrow unfolds more slowly or more quickly than back home? This mystery of slowing time is more than physics, it is a philosophical journey to the edge of understanding, exposing an irrefutable link between time, space, and gravity, a relationship so profound that revealing it alters how we view our place in the cosmos. It is a cosmic dance where seconds become malleable, and moments are stretched across unseen dimensions. As we explore this phenomenon, we will unravel why time's pace is not a given, but a dynamic player in the universe's grand narrative. We will look beyond the familiar storylines and stretch our thinking, venturing into fresh examples, time not just slowed near massive stars or between satellites, but working quietly in the everyday shadows of our solar system, and even influencing the way we communicate and navigate on Earth. Prepare to step behind the veil of familiar understanding, into a realm where time slows, where the clock's hands falter, and where the paradox of time and space challenges not just physics, but our very sense of reality. Because when time bends, we begin to glimpse a universe far stranger and more mysterious than we ever imagined. Time, as we experience it, feels unstoppable, a relentless river carrying us forward through the familiar sequence of seconds, minutes, and hours. Yet, when we turn our gaze to the cosmos, the seemingly universal flow begins to unravel. The very fabric of what we call time reveals itself not as fixed, but as something deeply flexible, intertwined with the invisible curvature of space itself. Before delving into why time slows down in space, it's essential to step back and reflect on an often overlooked shift in perspective, a shift that calls into question the foundation of how we understand reality. The universe does not treat time like a uniform tick-tock metronome. Instead, time is woven intrinsically into the geometry of the cosmos, a relationship first glimpsed through Einstein's theory of relativity. Yet this theory, profound as it is, can hide deeper subtleties if viewed only as a set of equations. Instead, imagine time as a path along a curved landscape, not a flat plane, but a terrain of hills and valleys, defined by gravity's pull and velocity's push. When an object moves through this terrain, the length of its journey through time changes, stretching and compressing like the surface of a calm lake disturbed by a stone. Consider a giant rotating space station far from Earth, spinning to create artificial gravity. Inside, the rhythm of life pulses, clocks tick, breaths come and go, decisions are made. But just outside its walls, where the spin no longer thaws the void, time can flow at a subtly different rate. It's not a large difference, imperceptible in daily life, but this tiny distortion hints that time is almost always fluid, sensitive to the environment in a way we never witness on Earth's stable surface. This means the passage of time is not an absolute truth locked in stone but a living element of the universe's architecture. To further grasp this, picture two explorers embarking on a journey not to distant stars, but to the orbit of Mercury right next door in cosmic terms, yet bathed in the intense gravitational embrace of the Sun. Here, time slows down measurably, a phenomenon scientists have observed with extraordinary precision by tracking the signals from spacecraft hovering in orbits close to the Sun. This effect is not merely an oddity of theoretical physics, it tangibly alters the communication between our probes and Earth. Messages stretch out, delayed by the invisible hand of gravity's warping not just over distance, but over time itself. Now, imagine standing on the surface of a neutron star, a remnant core, unbelievably dense, compressing the mass of our Sun into a sphere no larger than a city. The gravitational field is so fierce that time near its surface sags and stretches to dramatic degrees. For a single second ticking there, years might glide by in the distant cosmos. This gulf introduces a profound paradox. Time, for someone standing there, is normal, steady, yet for the universe beyond, it becomes a fleeting moment. The essence of reality splits, depending on your vantage point within this curved web of spacetime. The mind reels when we consider that every mass in the universe, planets, stars, even you and I, produces these subtle bends in time's flow. Time dilation operates at every scale, a universal ripple. On Earth, this effect is slight but measurable. Atomic clocks, so precise that they lose or gain no more than a second over millions of years, tick just ever so marginally faster on satellites orbiting above us. When GPS satellites calculate their positions, they must compensate for the minuscule slowdown of time caused by Earth's gravity. Without that correction, navigation systems would drift off course within minutes, casting a shadow over modern technology's very foundation. But this is not just an intellectual curiosity or a practical necessity. It reveals that time is a personal experience, locally sculpted by motion and gravity in a way that defies classical expectations. The universe has no single now. Instead, each observer moves along their own thread in the cosmic tapestry, experiencing time differently depending on their specific conditions. In the quiet dark of space, this difference can grow with astonishing consequence. More than attributes of distant stars or futuristic space stations, time dilation hints at a deep paradox of existence. It suggests that clocks, and the events they mark, are not universal anchors but subjective signposts along the horizon of reality. Buried within these paradoxes is the haunting realization that our conventional notion of past, present, and future fractures beneath the weight of gravity and velocity. The essence of simultaneity dissolves, leaving behind a world where time is as fluid and varied as the cosmic winds that sweep through galaxies. What does it mean for us, bound to this blue planet? It means that the universe's narrative is not written with a singular clock, but with countless, intertwined chronologies. Each journey through space becomes a voyage through a personal time, shaped as much by speed and mass as by distance. This insight reshapes not only physics but prompts us to question the very framework of causality and connection. As our understanding of time's strange elasticity deepens, it beckons toward mysteries still uncharted. How might this knowledge transform our future in space? Could we one day navigate the fabric of time itself, using its pliability to cross vast distances? The slowing of time in space is not merely a physical curiosity, it opens an unexplored dimension of experience, one where every heartbeat and every moment carries the signature of the cosmos's intricate geometry. To comprehend why time slows in space, then, is to glimpse a universe where time is not an external clock ticking against an unchanging backdrop, but an intimate companion to space and gravity, a dynamic, flowing element that bends and flows, shaping the universe's grand story. It is a revelation that forever alters our place within the cosmic dance, inviting us to see time not as a line, but as an ocean in which we are all adrift, swayed by currents we are just beginning to understand. To truly unravel why time slows down in space, we must abandon the comforting illusion that time marches forward uniformly, like the steady ticking of a clock on a wall. Instead, imagine time as a shifting, malleable phenomenon, something that breathes and stretches in the presence of motion and mass. At the heart of this lies a profound principle, one almost impossible to grasp but undeniably real. The very fabric of space-time bends and warps under the influence of gravity and velocity, and this distortion directly alters the pace at which time itself flows. Picture yourself floating quietly near a massive star, a celestial body so dense its gravity pulls relentlessly on everything nearby, not just pulling matter but warping the invisible geometry around it. In this intense gravitational field, clocks don't tick the same way they do out here, far from the star's influence. Seconds extend, minutes linger. Time dilates. This isn't science fiction, it's a phenomenon predicted by Einstein's theory of general relativity. The mass of the star curves spacetime, creating a kind of indentation or well, and in this valley of gravity, time slows down relative to regions more distant from the mass. Observers near the star age more slowly compared to those floating in less curved regions of the cosmos. Yet this gravitational time dilation introduces an unsettling paradox. If time itself is tied to space, and space bends under gravity, then time becomes intertwined with space's very geometry. That means time is no longer an independent, universal parameter but a relative dimension, dependent entirely on where you are, how fast you're moving, and how massive the objects around you are. This rewrites how we understand cause and effect, as events occurring close to a massive object might unfold at a dramatically different rate than those far away, creating islands of experience where time's flow itself diverges. What about speed? As humanity ventures beyond Earth, hurtling through space aboard spacecraft, our velocity isn't just about covering distance, it affects time's rhythm inside us. The faster one moves, the more pronounced this effect becomes. Even at speeds far below light's cosmic speed limit, subtle changes in the flow of time have been measured aboard satellites circling our planet. This phenomenon, known as special relativistic time dilation, shows that motion is inseparable from the passage of time. Imagine an astronaut traveling close to light speed for just a few months. Upon returning to Earth, they could age only weeks while decades have passed for those left behind. This isn't fantasy but a gateway introducing time as a dimension that hums to the pace of velocity, speed stretches or compresses the experience of time. You begin to see that time's flow is shaped not by some universal march but by relative experience moving through the cosmos. But what forces govern this strange relationship? Why does mass bend space and stretch time? To approach this, we consider a radical idea. Time's flow emerges from the fabric of the universe as a consequence of energy and information. Gravity is more than a force attracting mass, it's a curvature in the very latticework of reality, dictating how particles move, how light bends, and how clocks tick. The denser the mass, the deeper the curve. The deeper the curve, the slower the progression of time. A compelling illustration of this comes from the extraordinary precision of atomic clocks placed at different altitudes on Earth. When raised just a few hundred meters above the surface, these clocks tick slightly faster compared to their counterparts below. We live on a vast sphere where gravity weakens as you rise, and so does its effect on time. This subtle yet measurable difference shows time's intimate dependency on gravitational potential, connecting our everyday world to the vast cosmos beyond. Yet, the implications extend far beyond the laboratory or even our solar system. In the swirling heart of a black hole, gravity is so intense that space-time curves upon itself, leading to extreme time dilation where the concept of time may cease to operate as we understand it. This territory lies at the edge of physics and philosophy, where the universe dares to question the very meaning of before and after, and where time might fold into dimensions beyond human comprehension. The paradox deepens when we consider that while time slows near massive bodies or at extreme speeds, simultaneously, for any observer moving alongside the clock, time appears perfectly normal. This duality challenges the notion of a single, absolute temporal reality. Instead, reality becomes a mosaic of time experiences. You on your spaceship live in your space-time continuum, while someone else far away travels through theirs, each consistent within its realm but diverging between them. This phenomenon nudges us towards a mind-bending insight. Time is something we participate in, not merely observe. It is as much an experience as it is a measurement. The slowing of time in space is not just a scientific curiosity but an invitation to reconsider how we relate to the universe, to recognize that our perception of time is colored by our position and motion within the cosmic tapestry. From a practical standpoint, this understanding has revolutionized modern technology. Global positioning system satellites must account for time dilation effects both from their speeds and their positions away from Earth's surface. Had engineers ignored these relativistic shifts, GPS coordinates would drift by kilometers in a matter of hours, rendering the system useless. Time dilation is a ghost-like force operating subtly yet decisively in the technology woven into our daily lives. But beyond GPS, the phenomenon leads us to tantalizing questions. If time can be stretched and compressed by conditions in space, could this principle someday pave the way to advanced time-controlled travel or communications, shaping future voyages among the stars? Could civilizations well beyond our reach have harnessed these effects to explore or perceive the cosmos differently from our linear, earthbound experience? This interrelationship of time with speed and gravity constructs a universe that is inherently layered and multidimensional. Time becomes a river with fluctuating currents rather than a straight canal. Each moment carries the imprint of its spatial surroundings. For humanity, this means stepping into a cosmos where time itself is a destination, a frontier to be explored, rather than a backdrop for adventure. Understanding why time slows down in space challenges us to embrace a universe where time is an emergent property, a dynamic puzzle piece within the grand design of existence. It opens a door into realms where past, present, and future may not be fixed but fluid, where time's passage bends to the will of gravity and velocity, creating a cosmic symphony whose rhythms we are only beginning to discern. In gazing skyward, we now see the universe not merely as a collection of stars and galaxies, but as a vast chronometer, ticking unevenly across the expanse, where time itself becomes an elusive element, bent and stretched, carrying within it the secrets of distant worlds, ancient histories, and the profound mysteries that lie ahead. To confront this truth is to stand at the threshold of new understanding, where physics and philosophy merge, and where the slowing of time and space becomes not a problem to break physics, but a key to unlocking nature's deepest enigmas. Imagine drifting silently amid the swirling gases of a distant nebula, far from Earth's familiar rhythm, where clocks tick not as we know but in subtle, enigmatic ways, some moments lingering longer, others slipping away faster, sculpted by the unseen hand of the cosmos. This strange temporal landscape is not a quirk of imagination but a profound revelation emerging from the very fabric of space itself. The slowing of time and space is more than an isolated curiosity, it is a gateway into realms where the laws of physics reveal themselves not as rigid rules but as flexible tapestries woven with threads of energy, gravity, and the quantum whispers of spacetime. To expand upon this phenomenon, we turn our attention beyond the immediate cause, gravity's grip or velocity's clutch, and peer into the intricate consequences that ripple through the universe on scales both vast and minuscule. In the depths of black holes, where gravity distorts everything into near incomprehensibility, time's flow becomes a shadow play. Near the event horizon, seconds for an outside observer stretch into eternities for the traveler falling within. But even before such extremes, subtle temporal shifts occur wherever gravity warps space, revealing a hidden choreography between mass and time. Neutron stars, for example, with their incredible density, demonstrate time dilation in a manner that hints at realities too remote for direct experience but vital for theoretical understanding. These stellar remnants, spinning at dizzying speeds, warp local time enough to affect the atomic clocks of hypothetical probes or even hypothetical observers nestled amid their fierce magnetic fields. Yet the scientific implications reach into domains untouched by simple gravitational mechanics. Quantum theory intoxicates this picture with puzzles that reverberate through time itself. The interplay between relativity and quantum mechanics, still unsettled, suggests that time dilation might be a surface feature of deeper temporal entanglements, connections between particles across the cosmos that defy our usual concept of cause and effect. Emerging ideas propose that space and time may be emergent properties from a primordial quantum network, where time's flow is not linear but a projection from a more intricate, multidimensional reality. If true, the slow ticking of clocks in space becomes a shadow cast by the collapse of quantum possibilities, a mirroring of entangled states resolving differently depending on gravitational context. The practical implications are profound. Consider spacecraft journeying through regions where intense gravitational fields cause measurable but subtle time shifts. The astronauts aboard may experience time moving at a rhythm uniquely their own, compared to mission control on Earth. Their biological processes, aging subtly out of phase with Earth-bound counterparts, prompt questions that reach beyond physics into philosophy and biology. How does differential time passage affect consciousness? Could a human mind, complex and intertwined with neural rhythms, perceive these changes? Or would it alter the very sense of self and memory? The slow dance of time and space suggests more than physical phenomena, it hints at new dimensions of experience, where identity interlaces with the fabric of spacetime. This strange temporal malleability also shakes the foundation of how we understand causality. If time can slow and stretch, could signals, information, be transmitted in ways that subvert our usual timelines? While still speculative, theoretical work on quantum communication and gravitational waves suggests that under extreme conditions, the sequence of cause and effect may rearrange in unfamiliar patterns. In such scenarios, time dilation transcends its role as a passive effect, becoming an active participant in the unfolding cosmic narrative, influencing when and how events imprint upon reality. Furthermore, the uneven temporal flow offers a fresh perspective on cosmology itself. The universe, expanding and evolving, may be seen not only in space but in layered time horizons. Regions of differing gravitational intensity create temporal enclaves, zones where clocks run faster or slower relative to one another. This patchwork creates a cosmic mosaic in which the age of the universe is not a singular tick but a complex gradient, with pockets of reality experiencing their own temporal eras. Our observational cosmology, dependent on light that has traveled billions of years, faces the challenge of interpreting signals encoded in time that is not uniform but weighted by the mass and motion of intervening cosmic structures. Could this imply that the distant, ancient reaches of the cosmos have histories recorded on a different temporal dial? Entire epochs might have unfolded more slowly in gravity's grip, meaning the narrative of universal evolution is not a single scroll but a layered anthology, chapters whispered in many voices of time. This invites speculation that life elsewhere, if it emerged in such temporal enclaves, could perceive existence itself differently, not just in biology but in the very rhythm of experience, memory, and anticipation. To comprehend these implications fully, we must embrace time's paradoxical nature, both absolute in its inexorable forward arrow and markedly relative when measured from different vantage points in space and gravity. The slowing of time and space is not just an anomaly, it is a testament to the deep interconnection between existence and environment. It is an invitation to see time not as a passive dimension but as a dynamic interlocutor in the cosmic story, shaping and shaped by matter and motion. Therein lies the silent mystery. Time, though invisible, is a force that binds and separates, unites and isolates, revealing that when we gaze into the depths of space, we are gazing into the folds of time itself, bent, stretched, slowed, and warped. Each tick of the clock lost or gained is a whisper of nature's hidden architecture, a clue to the deeper mechanisms by which the universe sustains itself and reveals its secrets across the gulf of eons and light years. In this portrait, physics is not broken but expanded, enriched by the paradox of slowed time and space. It becomes a crucible where classical ideas meet quantum uncertainty, where gravity meets information theory, and where the silent passage of moments carries the weight of cosmic truths yet unraveled. This is the frontier where mystery and science entwine, inviting us all to reconsider time not as a fixed stage but as an active participant in the unfolding drama of existence. If we pause to reflect on what it means for time itself to slow down, we confront a question that reaches beyond corridors of physics and into the very essence of what it means to be. Imagine your own life experience through a vessel hurtling near a black hole's event horizon where eternity stretches and compresses in ways that defy intuition. Here, time does not merely crawl, it becomes a strange companion, slipping through the fingers of cause and effect, unraveling the neat chronology we cling to in our everyday world. This isn't just an issue of scientific measurement, it is a shattering of the foundational mold in which our reality has been cast. Our consciousness, tethered to the relentless beat of time's forward march, begins to falter in such extremes. What happens to identity when moments can last centuries for one observer, yet pass in an instant for another? If astronauts returning from deep space celebrations find their friends decades older, or vice versa, how does this alter the threads that weave together familiarity, memory, and understanding? Time, once a unanimous agreement of shared experience, fractures. It enables a cosmic solitude where simultaneity loses meaning. This challenges the notion of a unified now, urging us to accept a universe that is inherently pluralistic in its temporal narrative. Moreover, the strange dilation of time and space forces us to re-evaluate the fabric of reality itself. The seamless progression we take for granted dissolves into a mosaic of perspectives, each valid within its own gravitational field or velocity. Reality is no longer a single river flowing unidirectionally but a complex web of streams bending, splitting, and threading through the vast expanse of the cosmos. For consciousness, this implies that being isn't anchored to a fixed temporal horizon but is deeply intertwined with space, motion, and gravity. It hints at a universe where existence is not a static state but a fluid process, endlessly refracted by the conditions of its surroundings. Consider the implications for meaning and human purpose. If time slows near massive celestial bodies, is it conceivable that time itself is a kind of canvas upon which the stories of the universe are painted in variable strokes? Life's milestones, birth, love, death, assume new dimensions when we entertain that their temporal unfolding may vary radically depending on cosmic context. This cosmic variability invites us to embrace a humility in our perspective, recognizing that our experience of time is but one of countless variations scattered across the universe. Meaning, then, can no longer be confined to a singular, linear framework but must incorporate the humility of plurality, acknowledging that the rhythm of our lives is just one tune in a cosmic symphony. This perspective redefines the human hunger for permanence and continuity. In a universe where time is malleable, permanence becomes a shadow, slipping through the grasp of certainty. Yet this very fluidity grants a profound kind of freedom, to imagine existence unbounded by fixed temporal laws, to conceive of life as a resonance rather than a simple chronology. Here, the slowing of time and space morphs into a metaphor for our own encounters with change and impermanence, a mirror held up to the human condition's fragile dance on the edge of eternity. In this light, time slowing down near massive objects or at relativistic speeds is not merely a physical curiosity. It is an existential message encrypted in the architecture of the cosmos, a reminder that the passing of moments is deeply contextual, shaped by forces both visible and unseen. The universe whispers to us that our understanding of existence must stretch beyond human intuition. It beckons us to embrace paradox, multiplicity, and mystery at its core. To journey into space is not merely to traverse distance, but to step into a new realm of being, where time's familiar cadence dissolves and we are invited to rethink what it truly means to live. As we stand at this threshold, we realize that the slowing of time and space is akin to a philosophical riddle posed by the universe itself. What is time, if not a condition of existence that is as flexible and deep as the cosmos we inhabit? In exploring this question, our inquiry merges science with spirituality, observation with introspection. The enigma of time's slow waltz across the stars becomes a gateway, opening possibilities that defy simple answers and urge us toward deeper reflection on the intimate dance between mind, matter, and the infinite. Beyond the elegant equations and subtle symmetries that describe time's malleability, a deeper, unsettling current stirs beneath the surface of our understanding, one that challenges not only how we measure moments but what those moments might mean for the very fabric of reality. Imagine, then, that time's slowdown in space is not a mere artifact of physics but a hint of a far stranger truth, that time itself may fray, fracture, or even fold in ways our minds are ill-equipped to grasp. Consider the eerie scenario unfolding near the cosmic edge of a black hole's event horizon. Here, time dilates to such extremes that what for a distant observer might stretch into eons, could, paradoxically, seem instantaneous to a freefaller destined never to return. Yet this dissonance in experience is not simply a matter of clocks diverging, it hints at a fracture in the continuity of cause and effect itself. If time can slow, might it also splinter? Could discrete histories coexist, ghost-like, layered over one another, a cosmic palimpsest where what was and is become elusive, overlapping realms? As scientists contemplate this paradox, a more unsettling possibility emerges. The slowdown of time may be nature's warning of a profound instability at space's fringes, where familiar laws yield to something stranger than fiction. Some theorists propose that this deceleration signals a breakdown in the fabric of spacetime, a morphing of the continuum into a foamy tangle of quantum fluctuations. If so, time is not a smooth river but a churning torrent of uncertainty, where the past and future intertwine in a chaotic, unpredictable dance. Such a vision unsettles the very core of human experience. If time's flow can bend and crack, what becomes of memory, identity, and agency? For astronauts voyaging close to these cosmic anomalies, could their sense of self become untethered from the linear narrative we depend on? Might their consciousness fragment, stretching thin across diverging timelines like a prism fracturing light? We are forced to confront a disquieting paradox. As time slows, the self might simultaneously dissolve into multiplicity, revealing a hidden plurality within what we once thought singular. On a more macroscopic scale, the implications ripple outward to the fate of the universe itself. If regions where time decelerates wildly are windows into alternative temporal fabrics, could these zones anchor entire spectra of existence, parallel eons, variable histories, or dimensions beyond our sensory grasp? Some cosmologists speculate that these temporal distortions could form the building blocks of a multiverse, where each pocket of slowed time converts into a crucible of new realities, forever spawning divergent world lines. There is also an intimate irony in how the slowing of time and space challenges our human compulsion to seize and preserve the fleeting. For the spacefarer, each journey beyond Earth's embrace becomes an existential gamble. While they may return physically younger relative to those left behind, their experiences unfold in a realm where time's steady beat no longer holds sway. They inhabit a liminal zone, caught between accelerated aging on Earth and a suspended present among the stars, embodying a paradox of existence that defies the sentimental truth of shared moments. This mosaic of unsettling possibilities invites us to reconsider our place, not as masters of time's current, but as travelers drifting within its cryptic eddies. It suggests that the cosmos harbors temporal territories where the arrow of time bends back on itself, potentially harboring pasts and futures entwined in strange embrace. It beckons with an unsettling question: what if the linear progression we cling to so fiercely is but a surface illusion, beneath which the universe unfolds in a labyrinth of temporal enigmas? In this quiet, profound mystery, time's slowdown is no longer an empirical curiosity but a riddle charged with philosophical weight. It provokes us to peer beyond the comforting certainties of clocks and calendars and to imagine a cosmos restless with hidden folds and fractures in time's seamless tapestry. The unsettling truth lies there, in the shadowy margins between physics and metaphysics, where the slowing of time cracks open a portal to realms that challenge our very notions of continuity, cause, and existence itself. As we gaze toward these dark frontiers, we glimpse not only the strange mechanics of a universe in flux but the fragile tapestry of our own temporal identity. Time slows down in space, yes, but in doing so, it whispers of unknown depths, inviting us to surrender certainty, to embrace ambiguity, and to journey inward as boldly as outward, into the uncharted territories of what it means to be alive in a cosmos forever dancing with its own paradoxes. In the end, the slowing of time and space is more than a scientific phenomenon, it is an invitation to rethink the very fabric of our existence. Consider this: a single second stretches, warps, and bends depending on where you are, how fast you move, and the invisible grip of gravity around you. Out there, beyond Earth's surface, time becomes a pliable thread rather than an unyielding ruler, and with that, our understanding of experience itself begins to unravel. This isn't just the playground of theoretical physicists, or a quirky side effect for astronauts confronting the vacuum. It's a revelation that time, that invisible element we structure all life around, is neither universal nor absolute, but in flux, responsive to the cosmic environment. Imagine a pair of twins separated by fate, one journeying through the orbiting void near a neutron star, clocked within a realm so dense and intense that seconds drag like hours back home. The other remains grounded, his days metronomic and predictable, untouched by this stretching of time. Upon reunion, the twins don't just face different ages, they confront dissonant histories, two lives marked by discordant rhythms, one woven into the fabric of Earth's steady pulse, the other stitched into the slow dance of celestial extremes. This poignant divergence is not the product of fantasy but a natural extension of how gravity and velocity resculpt time itself, hinting at a universe where age, memory, and experience are relative quantities. And what of the implications beyond human lives? Could the gradual deceleration of time near massive cosmic bodies influence the lifespan of stars, the evolution of galaxies, or the whisper of dark matter yet to be understood? Perhaps the strange dilation of time serves as a cosmic slow-motion camera, allowing nature to choreograph processes too subtle and grand for human perception at ordinary scales. This introduces a fresh paradox, that the universe's slow moments are not anomalies to be measured but essential chapters in a broader story, episodes where time itself mellows to reveal hidden layers of reality. Even more intriguingly, this temporal malleability hints at a fundamental dialogue between space and time that defies intuition. Time's rhythm, once thought to be external and impartial, is deeply connected to spatial geometry and motion. The universe is less a clockwork machine and more a living organism, responding fluidly to mass and velocity with a tempo that is measured not by hands on a dial, but by the unfolding story of matter and energy writ large across the void. It is as though time and space are partners in an endless cosmic dance, each shaping the other's movements in subtle but profound ways. This challenges our deepest convictions, not just about the physics that governs the cosmos, but about our own inner lives. If time can slow, stretch, or compress depending on where we are in the universe, what does that mean for memory, identity, and the human experience of continuity? Are our personal narratives fixed lines through time, or shifting patterns that reflect an ongoing negotiation with the environment around us? The idea that time might flow differently beyond our familiar horizons invites a humbling acceptance that our reality is a localized phenomenon, a fleeting glimpse framed by our place in the cosmic order. In embracing this, we are confronted with an invitation as profound as it is unsettling. To truly understand time's slowdown is to acknowledge that the universe holds truths that evade conventional comprehension, truths that demand openness to mystery, a willingness to question not only our models of nature but the essence of existence itself. It becomes clear that time's most perplexing property is not just its variability, but its power to connect us to realms beyond immediate sight, to a universe rich with puzzles waiting to be discovered. Ultimately, the slowing of time and space exposes the delicate fault lines where science meets philosophy, where observation brushes against wonder. It is a reminder that the cosmos is not merely a backdrop to our lives but an active participant in the unfolding of experience, shaping the flow of moments in ways both subtle and profound. As we contemplate this, we glimpse something deeper, a cosmos alive with complexity, sensitivity, and an ever-present invitation to explore not only the universe outside but the dimensions of time that pulse within each of us. Imagine for a moment a clock, simple, steady, reliable in its ticking. Now, imagine that same clock placed aboard a spaceship hurtling toward a colossal black hole, or drifting in the quiet void between galaxies. The tick-tock that we trust to measure seconds here on Earth doesn't march forward at the same pace. Instead, it finds itself ensnared in an invisible grid of distortions, an enigma concealed within the fabric of the cosmos itself. This is more than a curious anomaly, it is a fundamental paradox that unsettles the very heartbeat of physics. To grasp why time slows in space, we must dive beneath surface metaphors and explore the nuanced dance between gravity and motion, a choreography that bends not only light and space but time itself. While it's tempting to think of time as an absolute river flowing relentlessly forward, this steady flow fractures when confronted by intense gravity or extreme velocity. We encounter what scientists term gravitational time dilation and velocity-based time dilation, but these are not mere abstract concepts. They are phenomena with tangible consequences and mind-bending implications. Envision a pair of twins, a thought experiment woven into the tapestry of relativity, but this time, let's shift perspectives. Suppose one twin remains on Earth while the other embarks on a perilous journey into the heart of a neutron star's gravitational field, a place where gravity is so intense that a single teaspoon of its matter would weigh billions of tons. Here, near this stellar corpse, time dilates to an extraordinary degree. For the twin in orbit, moments tick by normally; for the twin far away, years pass in the blink of an eye. When reunited, their shared experiences are irrevocably out of sync, disrupted by the complex entanglement of gravity and time. This effect, while poetic in its emotional resonance, has practical implications. Consider the satellites in the Global Positioning System, GPS, zipping around Earth at thousands of miles per hour and operating hundreds of miles above its surface. If the discrepancies in their onboard clocks due to time dilation were not accounted for, the precision we rely on for navigation, from guiding airplanes to unlocking smartphones, would crumble. These subtle shifts in the flow of time, imperceptible in everyday life, become profound at cosmic scales, requiring constant adjustment by ground control. In the quiet calibration of these mechanical sentinels, we witness a silent dialogue with the universe's most intricate laws. Yet, time dilation is not solely the domain of massive objects or high velocities. Even seemingly innocuous factors reshape the rhythm of ticking clocks. Experiments with particles called muons, short-lived subatomic entities created high in Earth's atmosphere, reveal that their fleeting existence is stretched out when they hurtle toward Earth near light speed. These particles offer a fleeting glimpse into how velocity warps the lifespan of matter itself, an unsettling alteration of the natural order embedded within the speed limits of the cosmos. Beyond technical precision, beyond subatomic intricacies, these manifestations of time dilation ask an unsettling question: what is the nature of causal order? In a universe where time itself can stretch and compress, can cause and effect lose their universal clarity? Physicists wrestle with the idea that under extreme conditions, such as near black holes or within the realm of quantum gravity, our traditional sequence of events might become ambiguous, challenging the foundations that support our understanding of reality. This conceptual quagmire finds an echo in the realm of entanglement, quantum mechanics' most cryptic feature. Particles entangled across vast distances appear linked in ways that defy ordinary chronology, changes to one particle instantaneously affecting another, regardless of the time elapsed or the space between them. Though separate from relativistic time dilation, this phenomenon hints that our conventional view of time as a linear sequence is incomplete, perhaps even illusory. Stretching further still, we ponder whether time's malleability suggests multiple temporal pathways, branching futures folding into each other like the pages of a cosmic book. If time isn't fixed but fluid, can the universe contain countless timelines where different versions of reality coexist, diverge, and converge? This speculative terrain, straddling the edges of physics and philosophy, opens doors to a universe infinitely more complex and vibrant than our linear minds can readily perceive. And what of human consciousness in this vast, flexible chronosphere? If the ticking that marks our lives can vary between locations in the universe, do our mental experiences, our memories, emotions, and sense of self also bend and twist under cosmic influence? Could astronauts orbiting the Earth, or future travelers nearing black holes, return with not only altered physical aging but with a transformed temporal perception, a sense of time utterly unlike anything experienced on the planet's surface? Finally, this interplay between space, gravity, and time hints at a profound cosmic harmony. Time's elasticity is not a flaw or limitation but a vital feature woven into the universe's architecture. It allows matter and energy to interact across scales unimaginable, shapes the life cycles of stars and galaxies, and bridges the gap between the infinitely large and the intricately small. In this shape-shifting temporal tapestry, we discern a universe that is not rigid and fixed but exquisitely dynamic, a living entity whose heartbeat resonates in the ebb and flow of time itself. So when we ask why time slows down in space, we are reaching toward an answer that transcends mere scientific formulae or technological nuance. We seek to understand the language in which the universe writes its story, a story where past and future are not fixed lines but rippling currents, where the mystery of time blurs the boundaries between what is known and what is yet to be discovered. It is a mystery that invites us to look deeper, to listen more intently, and to remain humble before a cosmos that still keeps its deepest secrets just beyond our grasp. Imagine for a moment standing at the edge of a cliff, looking out across an endless valley shrouded in mist. What you see is something timeless, yet you know that the scene is anything but static. Clouds drift, light shifts, leaves tremble. Somehow, in this quiet space between what you feel and what your eyes behold, time itself seems to falter, caught in delicate suspension. In this fragile pause lies a question that stretches far beyond human scales of measurement: what is the substance of time itself? In the cosmos, this question takes on a new, disorienting hue. Instead of the steady rhythm of a ticking clock, or the predictable march of days and nights, time behaves more like a fluid, unpredictable stream that both shapes and is shaped by the very fabric of space and matter. It moves differently depending on where you stand in the vast lattice of gravity, velocity, and energy. And yet, we often grasp for time as if it were a universal metronome, unchanging and impartial, only to discover that the universe holds a far stranger score. In this contemplation lies a deeper philosophical puzzle. If time's flow alters across different cosmic environments, how do we, as conscious beings anchored to particular moments, reconcile the fragments of temporal experience that diverge wildly from one place to another? It calls to mind the way different cultures on Earth measure and perceive time in unique ways. The Hopi people, for instance, see time not as a sequence but as a concurrent coexistence of events, while the Trobriand Islanders conceive of time as a series of cyclical seasons tied to sacred rhythms of nature. These human models suggest time is not an inherent absolute but a conceptual framework shaped by perspective and necessity. Now, expand that perspective outward, binding it with the knowledge that near a neutron star, a single second might stretch into many seconds far away, or that for a ship skimming close to the speed of light, years may pass back home in a blink. What does this imply for reality itself? Could it be that our very sense of what is now is a construct emerging from local conditions, not a universal truth? Perhaps now is a fragile blossom, blooming uniquely wherever it is rooted, then wilting as the cosmos turns. This lens transforms our understanding of existence from a static tableau into an ongoing dance between experience and environment. Our lives become narratives threaded through varying temporal fields, with each event a node where time's rhythm exchanges subtly with the structure of the universe. This interplay complicates the notion of destiny and free will. The future is neither wholly fixed nor entirely fluid but a shimmering spectrum in which decisions resonate differently depending on the temporal context. One might even say that time's malleability grants the cosmos a form of memory. Unlike the cold permanence of stored data, this memory is dynamic, written and rewritten by the gravitational webs and energetic flows crisscrossing space. A black hole's presence, for example, marks its surroundings not only through gravitational pull but through centuries of temporal distortion, imprinting a lasting, though invisible, record on the flow of time. It is as if the universe archives moments not in static snapshots but in a living scroll that unfurls differently for every observer. This raises a haunting, almost poetic thought: what if the universe itself is conscious of time's oscillations in some unfathomable way? Consciousness as we know it arises from neural firings and biochemical signals, but could there be broader, subtler echoes of awareness imprinted in the fabric of space-time? If time slows or quickens, does the cosmos itself pulse with a deeper form of attention, bearing witness to its own unfolding saga through these shifts, like a storyteller experiencing the story as it is told? For us, nestled amid these cosmic rhythms, the challenge lies in embracing uncertainty without surrendering to helplessness. The slowing of time near massive bodies or at relativistic speeds is not just a scientific curiosity but an invitation to rethink the connection between our existence and the universe's grand narrative. It provokes a quiet humility, that our place in time is both privileged and precarious, a fleeting resonance amid vast, intricate flows. In this quiet reflection, the slowing of time and space becomes more than a peculiar consequence of physics. It becomes a mirror, reflecting our own struggles with change, loss, and the relentless passage of moments. It invites us to lean into the mystery rather than rush to confine it, to savor the delicate pauses, the subtle shifts, and to recognize that in the cosmic dance of time, we are both dancers and audience, forever entwined with the unfolding rhythms of a universe that continues to rewrite the meaning of now.